What if I told you that in 2012, engineers in China invented a scanner that could see invisible ink marks and automatically extract exactly what you highlighted? Picture this: you're a student in 2010 trying to scan important parts from a textbook, but your scanner forces you to manually select each highlighted section one by one, taking forever. Traditional scanners were dumb, they just captured everything on the page. And if you wanted specific sections, you had to crop them yourself in the preview window, clicking and dragging rectangles around each part. And if you had 20 highlighted sections across multiple pages, forget about it. You were looking at an hour of tedious manual work just to extract your notes. So these engineers at Lite-On Electronics in Guangzhou, China, decided to solve this problem using something most people don't know about: fluorescent ink and ultraviolet light. Here's the brilliant part: almost all highlighter pens use fluorescent ink that reacts differently under UV light compared to regular white light. It's like having a secret decoder built into your highlights. But it gets even crazier. The patent also covers invisible fluorescent ink. Imagine marking up a document with completely invisible ink that only the scanner can see, protecting sensitive information from prying eyes. So how does this magical scanner actually work? Well, it uses two different light sources and takes two separate images of your document. First, it blasts your document with UV light, making all the fluorescent ink light up like a Christmas tree. The scanner captures this glowing image, showing exactly where you marked. Then it switches to normal white light and takes a second image. This one captures all the actual text and content on your page, just like a regular scanner. Now comes the clever part. The image processing unit compares both images using the UV image as a map to automatically extract only the marked regions from the normal image. The software is smart enough to detect different types of marks. It knows if you drew a circle around text, highlighted over it, or underlined it, and adjusts the extraction boundaries accordingly. For curved traces like circles or irregular shapes, it finds the extreme points left, right, top, and bottom, and creates a rectangle that captures everything inside. For highlighted text, it measures if the highlight is as tall as the text or taller, which means you highlighted over the words, and adds a small buffer around it. For underlined text, it detects that the mark is below the text and automatically extends the capture region upward to include all the words above the underline. Super clever. And the best part, it can handle multiple marks on the same page, simultaneously extracting 20 highlighted sections as easily as extracting one. After extracting all the marked regions, the system can automatically run OCR, optical character recognition, to convert the images into editable text files. But wait, there's more. The patent isn't limited to just fluorescent highlighters. It also works with pencil marks, chalk marker ink, and even oil-based pens. The key is that these materials reflect or absorb light differently at different wavelengths, so any two light sources with different wavelength characteristics can reveal the marks. The patent even covers visible fluorescent ink, which doesn't glow under UV, but changes properties like brightness or color, allowing the scanner to detect it in both images. For even better accuracy with visible inks, the system can cross-examine the marks in both images to precisely determine the boundaries of what you marked. The hardware setup is flexible too. It can be built into a flatbed scanner with a moving sensor, or work as a camera system positioned above documents. In scanner form, it uses a contact image sensor, or CIS, that sweeps across the page, switching between UV and white light as it goes. Think about the real-world application. Students could scan textbooks and automatically extract only their highlighted notes. Researchers could process stacks of marked-up papers in minutes. The invisible ink feature opens up security application. Two sensitive documents could have invisible marks that only authorized scanners can detect and extract, creating a physical encryption system. In offices, people could mark up printed reports with highlighters, then scan and automatically create summary documents containing only the key points they marked. For education, this could revolutionize how students study. Imagine highlighting a textbook, then instantly getting a digital study guide with just your highlighted sections. Legal professionals reviewing contracts could mark important clauses and instantly extract them for analysis, saving hours of manual document processing. Libraries and archives could use invisible marks to tag important sections of historical documents without damaging them, then digitize only the relevant portions. Medical professionals could mark key findings on printed test results and patient charts, then quickly compile them into digital summaries for patient files. Publishers and editors could mark up manuscripts with different colored highlighters, and the scanner would extract each color separately, organizing feedback by type. What makes this patent brilliant is its simplicity. It takes existing scanner hardware, adds a UV light source and some clever software, and creates a completely new capability. The boundary detection algorithms are particularly clever, adding precise offsets to ensure clean extraction, half a millimeter buffer for highlights, text height detection for underlines. The system even handles edge cases like overlapping marks that extend beyond text and irregular hand-drawn shapes, adapting its extraction strategy for each. Processing happens in real time as the scanner operates, no waiting for slow manual selection, just mark, scan, and instantly get your extracted content. The extracted regions can be saved as individual image files combined into a single document or converted to searchable text through OCR maximum flexibility. From a manufacturing perspective, this adds minimal cost to existing scanners. UV LEDs are cheap, and the image processing runs on the same chips already in the device. Yet the value add is enormous, transforming a commodity scanner into an intelligent document processing system that understands human markup conventions. Imagine future versions that could recognize different users by their ink types or highlighting patterns, creating personalized extraction profiles for collaborative document review. Combined with AI, this could analyze what types of content people tend to highlight, learning to automatically suggest important sections in new documents. The camera-based implementation opens possibilities for mobile apps that could use phone cameras with UV attachments to perform the same magic. For accessibility, this could help visually impaired users by extracting and enlarging only the most important marked sections of documents. Environmentally, it reduces paper waste by making it easier to digitize only relevant portions, instead of scanning and storing entire documents. This patent represents a fundamental shift in how we think about document digitization, from passive capture to active intelligent extraction based on human intent. Lite-On Electronics, the company behind this innovation, is better known for making computer components, but this patent shows their forward-thinking approach to imaging. Filed in 2012 and granted in 2014, this patent arrived just as mobile scanning and cloud document storage were taking off. Perfect timing. The implementation challenges were significant: coordinating dual light sources, precise timing for image capture, and developing robust mark detection algorithms. The patent includes 22 claims covering various aspects from the basic method to specific implementations, ensuring broad protection for the invention. While invented in China, this technology has global applications anywhere people use highlighters to mark important information in physical documents. So next time you highlight something in a book, remember that somewhere in China engineers created a scanner that can see exactly what you marked and extract it automatically. Pretty amazing, right?